I decided to do my stats project on the average mean difference of the steps that I take on a working day and a non-working day. The reason I chose this topic is because it is relevant to me, because I'm usually either working. On the days that I'm not working, I'm doing homework, or sometimes I go walking with my grandparents on different trails and stuff. My parameter of interest is going to be mu sub w minus mu sub m, which is the mean difference between steps taken during a working day and a non-working day for me. My null hypothesis is mu sub w is equal to mu sub n, and my alternative hypothesis is mu sub w is greater than mu sub n. And I will be working with a level of significance of 0.05. Here I have a table with all of the days, like the 30 days of the steps that I've taken while working at my job at McDonald's. And here I have a chart of the 30 days of the steps taken while I'm not working and doing other things like sleeping or walking or whatever it is I do on my days that I don't work. So to collect my data, I used a health app on my iPhone that just monitors how many steps I take and how many miles I walk and so on. I looked over a 2-month period in order to get my data, and I looked at the schedules that I have on my phone over the last 2 months to make sure that I was getting the correct days on what days I worked and what days I did not work. The sample for me was a convenient sample because I just went from the most recent days to from most recent to least recent days, because I have more of my recent schedules, less to say than the ones from 2 months ago or like further down the road. And my test statistic, I used a 2-sample independent t-test because it's a t-test because I'm looking at the average mean difference, and it's independent. It's a 2-sample independent one because I'm working with 2 samples that have no correlation to each other. Like, the steps that I take on a working day have no correlation or effect on the steps that I take on a day that I am not working. And I used my calculator to find my t-star and my p-value. And in my calculator, I went to StatCalc or stat test, and then the 2-sample t-test option, which is number 4, I think. And I got a t-star value of 3.42 and a p-value of 0.991. And 0.991 is greater than 0.05, so I failed to reject my null hypothesis. And by doing so, we do not have sufficient evidence to say that the steps that I take on a working day is equal to the steps that I take on a non-working day. And some limitations that I had faced during this project is the fact that I'd be doing more if we weren't under like stay-at-home orders, or like if we could go out more, then my steps probably on my days off would probably be higher than what they are, obviously. And if somebody wanted to redo something like this in the future, they could probably look at, and they could probably narrow it down and look at specific hours that you work, or somebody who specifically walks every day that they're off a certain amount of time, a certain distance, and they could just further the study in that way.